Hi all. Now we are going to discuss about the DSM, Demand Side Management, the definition and its objectives. So the DSM refers to the actions which are taken on the consumer side in order to reduce the amount of energy consumption. So the DSM strategies always have the goal of maximizing the end-use efficiency to avoid or postpone the construction of new generating plants. So we have said that there is always an increase in the demand day by day. So it is not possible to put up the generating plants every day in order to meet up the demands. So one way to curtail or stop the increasing demand of installed capacity is to reduce the energy consumption at the user side. So say you are getting a salary of 10,000 rupees per month, but just imagine that your expenses in a month is increasing. So the salary doesn't have that opportunity to increase above 10,000. So the only way to make yourself profitable is to reduce your expenses. So the same way you are trying to reduce the energy consumption at the user side. So all these demand side management techniques are being done at the consumer side in order to reduce the energy consumption. So we will see the various objectives of demand side management. So the key objectives are to, first one is to improve the efficiency of the energy systems. Rather than using a 100-watt incandescent lamps, can we replace it by a 10-watt LED lamps? We are getting the same amount of light output. Why can't you use an energy efficient LED lamp in order to reduce the energy consumption? That is, I am trying to improve the efficiency of the energy systems. Next is to reduce the financial needs to build new energy facilities. I cannot increase my generation. I cannot put up new hydel power plants. I need a lot of amount of money to construct that. So I am trying to reduce that. Next is to minimize the environmental impacts. That is putting up a new generating station. It has various kind of environment problems. So can we reduce that? So by reducing the energy consumption, then you are trying to reduce the effect on the environment. Next is lower the cost of delivered energy to the consumers. So if I am having a surplus of power, then it is also possible to sell this power at a lower cost. So in the case of Kerala, sometimes we are trying to import energy from the outside states. So we will be purchasing power at a higher rate. And in the same way, then the system cannot go into losses. So what they are trying to do, they are trying to bill at a higher unit or higher cost from the consumers like us. So if we are not trying to import energy from outside states, then we can go ahead with our own energy consumption or energy produced inside the state. Then the people will be billed at a lower rate because they are not trying to purchase at a higher rate from outside states. Next is reduce the power shortages and power cuts. So increase in the demand, the peak demand increases. Earlier cases we had the power cuts were there. So during 7 a.m. to 7:30 p.m. to 8 p.m. we'll be having the load curtailing is there. You're trying to power cut will be there because we are not able to suffice all the demands in that particular system. Next is to improve the reliability and the quality of power supply. So if there is an increase in the load, then there are changes in the frequencies will be coming, then the voltage variations will be coming. So you need to have a quality of power. At the same time, you should also provide a reliable power to the user. So these demand side management techniques will help us in achieving these kind of objectives. So the DSM methodology, several steps are there. The first one is to have a load research. So we have taken this particular example during our explanation on energy management planning. So there we have seen that this is in the case of a hotel industry where they have done a detailed load analysis. So they have taken that 49% is the heating, ventilation, air conditioning. Kitchen is consuming 9%. Hotel lighting is 9%. And the major chunk is which is the HVAC systems. And in that HVAC system, chiller is the main component which is consuming the power. Then cooling tower it is 16%. Air handling unit it is 29%. And the pumps are consuming 14%. So they are having a complete load research. which equipment is consuming power during which period of time. So they will also generate a load curve like this. So in that particular time, so during the peak time, they will find out which component or which part of that particular equipment is consuming more amount of power. So they will be having a detailed load research. And after that, they will be going ahead with the Lordship objectives. So you'll be having this is your power and this is your time. So this is nothing but your load profile. So they are trying to see whether how we can achieve the demand side management objectives. So whether you can clip that particular peak during the peak hours of operation. So that is peak clipping. So rather than operating like this, can I operate like this? This question. Next one is energy conservation. So energy conservation is this was my load profile, and if I am trying to put new efficient systems in place, then I will be consuming lesser amount of power. One such example is I'll be having a motor car of 15 kilometer per liters of fuel, and if I am able to drive that particular vehicle at 18 kilometers per liter, that is at an improved mileage, what I am trying to do, I am trying an energy conservation in that particular system. So better operating procedures or better technology or better driving ways, I am trying to reduce the energy. So the peak demand is getting reduced. Next is load building. That is in the case of power plants. I have said that the power plant efficiency will be maximum around 80 to 90% of that particular load. So if I am able to build up rather than operating majority of the power plants at 10% or 20% load, whether I am able to utilize the full capacity of a particular power plant. So that is made possible by the load building procedure. Similarly, in the case of valley filling, in the case of power plants, whether I can, rather than having a varying load, whether I can have a constant load, that is by valley filling. So rather than having a load like this, I may have a load which is almost constant like this. So that is with the help of valley filling. So the valleys are being filled so that I am getting a constant load. Next is with the flexible load shape. I am able to adapt with any of the load shape which is possible, so that my power plant is also benefited. Next one is load shifting. That is during the peak period of time, I can shut down the non-essential loads, and those non-essential loads can be operated at a normal hours or during the off-peak hours. So these are the various load shape objectives. So once these are being finalized, then we'll be going ahead with assess the program implementation strategies. What are the strategies which we can improve in order to achieve the demand side management? After that, it is going to the implementation stage and then to the monitoring and evaluation, whether I have achieved it or not, or if I have achieved it, how much percentage of that I have achieved. So it is always requiring a monitoring and evaluation phase. So there are various types of demand side management measures. One is the energy reduction programs, another one is the load management programs. The load management program is nothing but the operator changing the load pattern. That is, from the load curve, we are trying to see that whether I can curtail the loads during the peak period of time, and having less demand during the peak times, and during the off-peak hours and during the normal hours, can we shift the loads? So that is with the case of load management programs. In the case of energy reduction programs, the best one which we can take it an example is that replacement of all incandescent lamps by CFL lamps some 3 or 4 years back, and now it is again replaced by LED lamps. So that is one such initiative from the government in order to improve the lighting efficiency in houses and also in the street lights. And another program is the standards and labeling. So you must have seen that the 5-star rated refrigerators and 5-star rated air conditioners, they consume lesser power when compared to the 2-star or a single star equipment. So these kind of things are such examples of energy reduction programs. So people are trying to buy a 5-star rated equipment, even though they give some extra 1,000 rupees or 2,000 rupees for buying that particular product. They are getting benefited by reduced energy bill during that operating hours or operating years of 10 or 15 years. So these are the two types of DSM measures. So with this kind of demand side management, there are basically the benefits are not only to the utility but also to the consumer and to the society. Also it happens. So we are speaking only from the utility benefit, that is a lower cost of service, improve the operating efficiency, then have a reliable supply and reduce the capital needs in order to put up new generating stations. And it has a better societal benefit to reduce the environmental degradation, conserve the resources. That is, a better efficient operation of an equipment is trying to reduce the energy consumption. So that means you are trying to reduce the consumption of fossil fuels in order to produce energy. Then it is also trying to reduce the greenhouse gas emissions, which we have discussed in our first lecture. And from the customer benefits, reduced electricity bills comes into picture, improved value of service, and maintain or improve the lifestyle and productivity. So that an old air conditioner will be consuming lot amount of power, but newer air conditioners consume lesser power. So that means it is being people's life is getting improved by having a better lifestyle by using newer equipments which is consuming lesser power. So that is the case with the demand side management techniques. The various types of benefits, its objectives are being discussed in this lecture. Thank you.